Welcome back. In this video, we're going to start chapter 4, which focuses on graphs and two-dimensional algebra. As always, when we start a chapter, it's a good idea to look ahead and see what it is we're getting into before we get into it. So taking a look, this chapter has 7 sections in it, going through each. The first one, 4.1, says use the rectangular coordinate system. This one will be about the XY plane. If you've learned a little algebra before, it'll be about the XY plane. 4.2, graph linear equations in two variables. So this will be about graphing lines. 4.3, it says graph with intercepts. So this is more about graphing lines, but in a specific way. 4.4, it says understand the slope of a line. That is basically a numerical measure of how steep a line is. 4.5, use the slope-intercept form of an equation of a line. And we'll see what that is when we get there. 4.6, find the equation of a line. So given 2 points on a graph or 2 points in the plane, as we'll see, how do you find the equation of a line? And then finally, 4.7, graphs of linear inequalities. We'll see what that is when we get there. The first section, though, 4.1, is about the rectangular coordinate system. So we will start that now. Basically, in this chapter, we're starting to look more at the relations between two variables. Up till now, we focused on equations that had just one variable in them. And frequently in math class, as in life, you're interested in the relationships between a couple of variables. How much you get paid, it depends in some way on how many hours you work, perhaps. The temperature of the sidewalk outside depends in some way on the time of day, as well as other things. The length of your arm from your shoulder to your elbow is related in some way to your overall height. So there's a couple of instances where we have two quantities related to each other in some way. And so for that reason, rather than just having a single number line, we have two number lines. And the way that we arrange our number lines is so that they intersect at the 0 for both of the number lines. The horizontal number line is the number line we have always had, picture that you see here, and that's our X number line. In this context, it's called the X-axis. So that's axis, A-X-I-S. The other number line is the Y number line, or Y-axis. And like I said, they intersect at the point where it's 0 for both lines. The plural for axis is going to be axes, so they're X and Y axes. Those X and Y axes divide your paper or my screen here into 4 quadrants. The 4 quadrants are numbered using Roman numerals, starting at the upper right and going counterclockwise. So there's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Where let's do ordered pairs next. This forms a grid on the screen or on your paper where we can identify relationships between X and Y values. Here I've put a blue dot corresponding to 5 on the X number line and 3 on the Y number line. This would give us a pair of numbers, 5, 3. Note that that's different from the pair 3, 5, which would be 3 on the X number line and 5 on the Y number line. When you're making an ordered pair, the order matters. The X always comes first, the Y will come second. So the first one I drew, 5, 3, that's an X of 5 and a Y of 3, different from saying X is 3 and Y is 5. That's an ordered pair. The point where or the pair corresponding to 0 on both number lines is called the origin. You could think of that as basically being the starting for both of the two number lines. Okay, so a fair bit of terminology in this first part, axes, quadrants, ordered pairs, and so on. So there's a bit there, but you don't need to really memorize those. You'll kind of pick up the definitions as we go through. All right, the whole purpose of this picture is so that we can then look at illustrations of how the X and Y quantities or variables are related to each other. One of the main tasks we want to do with this setup is to be able to plot points. By the way, when I say plot points, that's the same as graphing points. You can treat plot and graph as synonymous here. So remember that the ordered pairs are ordered, and so the x will be on the left and the y will be on the right. So when we see 2, 4, I'm going to go to 2 on the x. Let me make that a little bigger if I can. We'll go to 2 on the x number line and 4 on the y number line. And put a dot there, and I'm going to label that one A. Okay. 4, 2, that will be 4 on the x number line and 2 on the y number line. If you played Battleship as a kid, you know how this goes. Okay. Only in Battleship, it's numbers one way and letters the other way, right? This one, it's numbers in both directions. Okay. So we've got A, we've got B, C, -1, -5. So we'll be -1 in the x direction, -5 in the y direction. Okay, then D, 0, -4, that's on the negative y-axis. 0 for x, -4 for y. And then E is -5, 1. We went to -5 in the x direction and 1 in the y direction. And that will be E. Plotting or graphing points in the plane. Okay, in this example, we're doing the exact same thing backwards. This time I've got 5 points graphed, and we want to write down the ordered pairs corresponding to these points. We will have A, B, C, D, E. Okay, starting with A, that is x is 5 and y is 1. That's the point 5, 1. For B, B is in quadrant 2. X is -3 and y is 4. For C, x is -4 and y is 0. For D, x is -2 and y is -4. And finally, for E, we have 3, -3. Okay. One of the main uses we have for the XY plane, at least at this point, is to draw pictures of solutions of equations in two variables. So we need to talk about equations in two variables next. So definition, an equation that looks like ax plus by equals c, where at least one of a and b is not 0, is called a linear equation in two variables. It's two variables, x and y. That's where that comes from. Here, the a, b, and c are constants. Those would be actual numbers. The variables are x and y. The part that makes it linear, in case you were curious, is we don't have any x squareds. The y is not underneath a square root sign. Nothing crazy like that. We don't have 3 over x plus 5y is 12. The x is not in the denominator. It's not underneath a root sign. The exponent on it's just a 1. That's what makes it a linear equation. None of that fancy stuff for now. So some number times x plus some number times y equals some number. Okay, linear equation in two variables. Solutions to linear equations in two variables are pairs, x, y, and the graphs of them are going to be lines. Up until now, when we have an equation like 2x plus 1 equals 13, there the solution is a single number. In this section and going forward, our solutions are going to be pairs of numbers. We need a value for x and a value for y. So here, we want to know in this example, which pairs are solutions to 2x plus 3y equals 6. And how you can do this is by substituting in x into the formula. So here, 2 times 3 plus 3 times 0. We want to know if that's 6 or not. So the pair in A here, x is 3 and y is 0. I replaced x with the 3 and the y with 0. And we want to know if we get a true statement or not. That's true. So A will make a solution to that equation. 2, 0. 2 times 2 plus 3 times 0. Is that equal to 6? 4 equals 6? No, that's false. That's not going to be a solution. Let's try C. 2 times 6 plus 3 times negative 2. We want to know if that's 6. 12 minus 6 does in fact equal 6. So that would be a solution. When we're working on linear equations in a single variable, we talked about the possibilities of getting a conditional equation, a contradiction, or an identity, where you had one number for a solution, no solution, or infinitely many solutions. In the case where we have two variables, it's a little more complicated, and that's why we're going to end up having pictures to help us understand the relationship. Okay, more examples. We want to complete the table here to show solutions of the equation y equals 3x minus 1. Here, we're given values of x of 0, 1, and 2, and we're going to calculate the corresponding values for y. We'll start when x is 0. So if x is 0, y will be 3 times 0 minus 1. That is 0 minus 1, or negative 1. So the y value corresponding to an x of 0 is negative 1, and the pair that makes up the solution is going to be 0, negative 1. Okay, take a minute, pause the video, and see if you can figure out the solutions corresponding to x equaling 1 and x equaling 2. Okay, so next, when x is equal to 1, y will equal 3 times 1 minus 1. That's 3 minus 1, or 2. Here our y value will be 2, so we'll have the pair 2. Lastly, when x is 2, y will equal 3 times 2 minus 1. That's 6 minus 1, or 5. Our y value is 5, and so our pair is 2, 5. Solutions to linear equations in two variables are pairs of numbers, x and y. Let's try the same thing again, only we have a different equation. 2x minus 5y equals 20. And this time we're given two different x values and we're given one y value. So let's try to get this done. So let's first, when x is 0, so x is 0, we'll replace x by 0 and calculate y. Okay, 2 times 0 is 0. So it's lucky that you've practiced solving equations in one variable up to this point, because we're going to be doing that a lot. So here y is equal to negative 4, and so our pair is 0, negative 4. In the next one, we're given that y is 0. So if y is 0, we'll have 2 times x minus 5 times 0 equals 20. 2x minus 0 is 20. 2x is 20. And so x is 10. When y is 0, x is 10. And so our pair is 10, 0. For the last one, we have x is negative 5. So let's see that. 2 times negative 5 minus 5y is equal to 20. Negative 10 minus 5y is 20. Negative 5y is 30. And so y is negative 6. And so our pair here is negative 5, negative 6. Moving on. A couple more examples. Here we're going to find three solutions of y equals negative 4x plus 1. Here there will be infinitely many solutions. So it's up to you to choose an x and calculate the y. And we're going to do that a total of 3 times. So at this point, pause the video and then restart it and see how you did. All right, so I'm going to use x's of 0, 1, and 2. Of course, you possibly chose different x's, and that's okay. But the method's going to be the same, and you'll be able to check how you've done. So here, when x is 0, we'll have y equals negative 4 times 0 plus 1. That's 0 plus 1, or 1. So when x is 0, y will be 1. When x is 1, we'll have negative 4 times 1 plus 1. That's negative 4 plus 1, or negative 3. And then finally for 2, we'll have negative 4 times 2 plus 1. Negative 8 plus 1 is negative 7. So the pairs are 0, 1, and 1, negative 3, and 2, negative 7. Okay, like I said, you probably chose different x's than I did, and that's okay. But you should be able to tell how you've done by substituting in your x's and calculating y's. Okay, so we're going to try this one last time. We have equation 4x plus 2y equals 8. And for this one, I'm going to choose x's. You want to choose x's that are nice and convenient to work with, I think. Although you could choose any x you want. You could put 100,000, you could put 5/16, and 2.08 if you want. You can put in any x you want, but it's going to be easiest if we choose relatively easy numbers to work with. This time I'm using an x of negative 2, 0, and 10. Okay, and so we're going to evaluate or substitute our value of x into the equation and calculate the corresponding y. Okay, so here we're putting negative 2 in for x. We're going to solve for y. Okay, it looks like y is 8 when x is negative 2. If x is 0, we're going to have y as 4. And then for 10, let's see what we get. All right, looks like negative 16 for y. So the solutions I have are negative 2, 8, 0, 4, and 10, negative 16. All right, so this takes us to the end of this first section, actually. We learned about the xy plane. This is the rectangular coordinate system I'd mentioned is called the xy plane. It's also called the Cartesian coordinate plane. We learned about that. We learned about ordered pairs, quadrants, and axes. We saw how to plot or graph points in the plane. We saw how to read points off where they were already graphed. We're able to write down the coordinates. And we saw how to find solutions for a linear equation in two variables. That takes us to the end of this section. Let me know if you have any questions, and have a great day.